I took first service oil from 12 new motorcycles. The moral of this story is so compelling, we'd better start from the beginning. So, I was just contacted by a cleanliness technician at a major car company, and their job is to run first service oil through a software-equipped microscope that counts the number of particles. It's like a report card for how clean the manufacturing is. And this person has offered some extremely expensive lab hours to run tests for us. But now we have a chance to test the stereotypes objectively. Now, our method is prescribed by the anonymous scientist. What she said to do, and it's not necessarily a woman, but let's pretend, because she said to warm the oil in preparation. That's what she said. Prepare unused sterile containers to trap all fluids. That's what she said. Shake vigorously. That's what she said. Then take a 100 milliliter deposit. But if I had to ballpark it on a scale from 1 to Italian, the cliches are looking accurate. Hot off the plane are results. And immediately there's a problem. The Chinese motor was so full of shit, it broke the fancy microscope. Seriously, these are just the contaminants from a quarter of our sample. The lab software couldn't analyze any more, so they tested 25 milliliters and multiplied by 4. Remember that we're talking about carbon and metal shavings, but also cloth fibers, sand from molds, plastic from packaging, all things you'd find in an assembly area, but not things you'd want in a cleanly and precisely built motor. See, the small particles mean grinding, blasting, abrasion, premature wear. Medium particulate will cause actual mechanical alterations like scratching and imprinting, while the biggest stuff can lead to clogging and engine failure. All bad.
Can't say I'm a fan of the video. If you want to hear why, stick around. Okay, so the whole premise of what Fortnine are doing is they're saying, hey, let's take some oil from the first service or before the first service, let's test it, and from that we can determine the greatest of all time motorcycle manufacturer. So what I'm going to do is I'll explain a bit about industrial oil testing, which is something I do all the time, and I'm going to explain why I think Fortnine's whole sampling process is flawed, and then why their test methods really aren't relevant to our motorcycles, and determining the greatest motorcycle manufacturer of all time. All right, so why should you listen to me on this particular topic? My background's in mechanical engineering, and for over 20 years I've been working on earth-moving equipment, cars, trucks, motorcycles, and fixed plant, and pretty much all that time I've been using oil analysis to help me understand the condition of a machine. And I'm currently working for a startup company, and we do advanced analysis of oil samples for mining equipment. So I'm not the greatest expert in the world, but I've been doing this for quite a while, and I feel like I can add some value to this conversation. All right, so for context here, this is, and I've covered the title, industry standard oil analysis that we might do in industry, and I do with businesses all the time in the mining industry. So the premise is you take a sample at a regular interval. So you've got regular data points coming in to help you understand what's going on. You take those oil samples and you send them to a lab for some testing. They help you with the testing that they do. They'll help you determine the source of the contamination, whether it's being generated internally inside the compartment, like an engine, or whether it's coming from the outside, like dirt or water or anything else that's getting into that machine. They'll also help you determine the size of the contamination, because it is relevant because of the clearances in some components. That size of the contamination might be important, and then that really helps you understand whether the machine is okay or not okay. And if it's not okay, you should do something about it so you can prevent any further damage from occurring. Now, while our friends in Fortnine seem to imply that this is hideously expensive activity to undertake, it's not really. It's about $30 per sample around the world, give or take. It's not far off the mark. We're not talking about hundreds of dollars to do one sample. We're talking about $30 to do a sample. And the sort of work I do now, I work with companies that test thousands of samples every month. So this is not something new. This has been around for 20, 30, 40 years almost. and it's a very well-known technique for assessing condition of machines. All right, in terms of taking samples, there's two ways that in industry, how we do it in industry, whether it's with a vacuum pump or live sampling. And vacuum pump, that photo you're looking at there is my vacuum pump, and you literally take a little bottle, fit it to the pump, and use the pump to suck the oil out of the sump. So this goes into the sump, and we're very careful about where we put this tube in terms of how far into the sump it goes. And then we draw out whatever sample size we need. As you can see in the second photo for live sampling, that simply is a valve that's on an oil gallery on the machine. It's got a little valve in it, a bit like the valve in a tyre on your motorcycle. So if you push the pin in the centre in, the air can come out of a tyre. Works very much the same. You push the pin in and the oil can escape from that compartment, and it just goes straight into a jar. You put the cap on it and you mail it to the lab, and there you go. That's where the oil comes from. Right, so if you wanted to get this done, just about all the major earth-moving equipment manufacturers provide this service. So I've got a lot of experience with Caterpillar equipment. If you've got a Caterpillar dealer somewhere near you, there's a pretty good chance that they provide this sort of a service. Plenty of other, equipment manufacturers provide the service as well. So it's not hard to get this sort of testing done. And on top of that, there's plenty of third-party sort of independent labs, whether they're associated with an oil company or whether they're just a straight lab that provides that sort of testing services. You can get this sort of work done pretty much anywhere around the world. Now, all these labs have got quality accreditations too. They're not backyard operations. They're professional laboratories, and this is the sort of business that they undertake. The equipment they use is quite expensive, obviously. It's laboratory-grade equipment, and it's very carefully calibrated, and as part of the accreditation and the quality standards, those calibrations have to be maintained. So you can be pretty confident that you're getting a very good quality result from the lab. Now, you could do this analysis on your motorcycle if you really wanted to. If you were that pedantic about it and you were that interested, there's nothing stopping you doing it. You could take a sample of oil from engine or transmission or whatever the compartment is on your bike, send the sample to the lab, and they would run their tests and they would give you a report card back, and we'll look at a report card in a minute. But single data points aren't that useful. So in terms of oil sampling, working out what's happening over time on a trend is way more useful, is to see, hey, this is what normal looks like, and then if something changes and it's obvious in the sample results, that's an indication that you need to take some sort of action. So a single data point, one oil sample really isn't that helpful. So certainly wouldn't be recommending you do that. Okay, so the testing that the labs do, they really want to try to find out what's in the oil. And for the small stuff, and I say small stuff, I mean under 10 microns inside. So a micron is 1/1,000,000th of a meter. So you've got a meter is divided up into 1,000 millimeters, and then a millimeter is divided up into 1,000 parts, and that's one of those parts is a micron. So very small. So the small stuff, under about 10 microns in size, you detect with something called spectroscopy, and the ICP is a common tool that's used for that part of the testing, and it can identify individual elements and their concentrations in the oil sample. And when you've got a combination of specific elements in the oil sample, that would indicate a particular type of wear mechanism happening in that machine. And skilled interpreters can look at the report cards and they can say, oh, if I see that and that and that, that means this is the problem that's happening inside the machine. On top of that, the labs can also provide some testing to identify the particles that are bigger than 10 microns in size. And in contrast to what Fortnine are doing, a lot of the time the labs that I work with use something called optical particle counting. So there's a transparent tube, you run the oil through the tube, you shoot a laser at the tube, and if there's particles in the oil, they will scatter the laser beam, and then there's a bunch of sensors around there, and they pick up the scatter, and they infer from that how much stuff is floating around in your oil. So it's an automated process, and they give you some values that indicate the amount of particles in certain size channels. So we'll talk about that when we get to the report in a second. So the only thing with particle counting, it tells you how much stuff is in there at a particular size, but it doesn't tell you what it is. So it could be cats and mice and birds floating around in your oil, or it could be metal, could be sand, could be anything. You really have no idea without doing additional testing to identify what those particles actually are. And that's useful, again, for indicating trends. So if the trend is saying, hey, there's more and more contamination in this compartment, it's probably suggesting you need to do something about it. So other tests that the labs can do to help you out, infrared tests, which sort of indicates condition of the oil, water content. So if there's water coming in from external, whether there's a breather that's leaking or passing water, or someone's been a bit energetic with a pressure washer and they've blown some water into the machine. Fuel content, so in an engine oil, if you've got, say, a leaking injector or something, and that fuel is getting into the oil, then you can detect, well, there's tests to detect the fuel content, so it indicates, hey, there's probably a problem with an injector. Oil viscosity, so in the example of fuel, if you've got fuel going into your oil, the oil's going to get thinner and thinner, and it gets to a point where that oil is so thin, it doesn't do its job to protect the parts that it's keeping separate. So oil's viscosity is a very important one. Particle quantifiers really measure the amount of larger iron-based particles, so they use magnets to detect that. So obviously iron's the only magnetic element you'll probably find in a machine. So that just indicates, hey, if there's ions going up all the time, something's probably wearing out inside the machine as well. And then there's visual tests where you can literally take a photo of the filter media to cut the filter open, or you use a laboratory filter and you run the oil through the filter. You catch all the stuff on the filter paper, and then you use a microscope, or like a microscope with a camera on it, and you can take some photos of it. And yeah, skilled interpreters can also identify from the material on the filter paper. They can say, oh yeah, that's coming from this type of component, and it's generated from this type of wear mechanism. So again, quite specialized and useful in some applications. Here's an example of a report card, and this is a snip from a report provided by a company that I work with. And you can see these tables here. So these are all just the different samples on different dates. And these are the wear metals, so lead, iron, aluminium, copper, chrome, tin, and nickel. And they're tested using this method, so ASTM D5185. For ASTM is the American Society for Testing of Materials. So it's a standard test that they use to identify these concentrations. So these are parts per million at that test time. So in this particular example, so for lead, it was at 7, then it was at 4, then it was at 4, then it was at 1, and then it went to 18. And now it's at 11. So probably something to look at here, because the lead started to increase over time. And you can see the comments from the interpreter. Lead is elevated at 11 ppm, blah, blah, blah. So they're making a suggestions of what the contamination is coming from and what they should do about it. So you got wear metals, you got contamination. So that's typically silicon, is typically dirt. And sodium might indicate coolant entry. Oil additives, so there's a lot of additives added to oil for specific purposes, and these elements generally indicate the quantity of the additive present in the oil. And then we've got the infrared tests that we talked about. So TBN is total base number, then you've got soot, glycol's coolant, water part per million, fuel dilution, oxidation, nitration, sulfation, total acid number. So there's a bunch of different tests that can be done that are part of the suite of tests that the lab offers. And they can be used depending on the circumstances, depending on how much money you want to spend. Some of these cost a little bit more. So if it's really important to you, you might go and choose to do some of these other tests. And then here in this particle cleanliness analysis, so ISO code 4406. So ISO 4406 is the international test standard used for quantifying particles, particle counting. So there's another standard that's used for the testing. This is the standard that's used for reporting. So in the 4 micron, 6 micron, and 14 micron channels, there would be a number reported here. In this particular one, it said, as a result of high contaminant, unable to conduct particle count, please check filters. So it's suggesting that this particular oil sample was so badly contaminated, they couldn't do a particle count on it. So this is a very common report. And again, companies I work with would see hundreds or thousands of these in a month. Right, so the premise of what Fortnine was saying was, like, let's take first service oil. So they're taking oil from 12 different bikes or 12 different manufacturers. So if we're going to do an apples with apples comparison, are we looking at oils that are all exactly the same type, grade, and specification? No. Were all the oils in service for exactly the same time? So when they say first service, that means the first service interval needs to be identical. So does a BMW and a Ducati and a Yamaha and a Harley all have the same first service interval. So I'm not going to suggest they do. I'm not going to suggest they don't either. So you'd have to make sure that they're all identical. So is this oil sample representative of the oil that's circulating in the engine? I want to talk about that a little bit more. And was the sample extracted in a manner that reduces the chance of getting any contamination into like the bottle? So keeping these bottles clean when you're taking samples is critical. And often the labs will be able to identify that, hey, there's a lot of dirt in this sample, but nothing else is showing up in the sample at all. So we think you've got a bad sample because the bottle's got dirt in it before you took the sample. Okay, so the process the guys used for the testing that we saw in the video was they dumped all the oil out of the sump, they mixed it into a big bottle, and they shook it all up, and then they put it into other small bottles for sampling. So firstly, milk jugs or juice jugs that they're using in those videos aren't sterile containers that are used for storing oil. So anything that's in that container, so yeah, but we washed it out with some water. Well, how do you know there's not water already in that container still when you took that sample? So you're contaminating the sample by using a non-sterile container. The foil pan used for catching the oil, man, that's not sterile either. So who knows what dirt or dust has been floating around the atmosphere has landed in that pan before you took the oil sample. So basically, you're contaminating the sample before you've even done the testing. And like we see this in industry all the time. This is a pretty common problem. And it really comes down to the people and the processes used to extract these oil samples. It's quite important to do it properly. So mixing all the crud that comes out of the sump of your engine into your oil sample, that's not representative of the oil that's going around your engine. Let me talk about that a bit further. Here's just a random drawing that I made up of a cross-section of an oil sump showing the oil plug in the bottom of the pan, which is where you would drain the oil from. The brown line's indicating, hey, that's where the oil level is in that particular sump. And there's a suction tube that goes into the sump, whether it be a truck or a car or a motorbike, whatever. They're not all identical, but for the exercise, let's go with the flow. So that suction tube goes to the oil pump. Now, there's a reason why that suction tube is about halfway into the sump and not all the way at the bottom, because at the bottom there in the red is all the crud that's floated out of the oil or settled out of the oil. So no oil is perfect, no engine's perfect, no machine is perfect at all. So there is going to be some contamination inside that compartment, no matter how good you are. So what typically happens is because it's, gravity pulls it all to the bottom of the sump, it tends to end up in the bottom of the compartment. Now, if that was a hydraulic tank, it'd be sitting on the bottom of the tank. If it was a transmission, it'd be sitting in the transmission pan, or the engine would be in the sump. On your motorcycle, it's going to be at the bottom of the engine somewhere where gravity's drawn it down to. So in this case, if the oil pump is sucking the oil from the middle of the sump, it's not picking up the stuff that's in the bottom of the sump. So we don't care about the stuff that's red in my drawing here because it's not going into the engine. Now, if there was something floating around in the oil that hadn't been settled out yet and it got sucked up that pipe, sure, that could be a problem. But what else do we have in an engine that's there to protect all the components? Yeah, the filter. So whether it be on the suction side of the pump or the discharge side of the pump, there'll be a filter. And the whole point of the filter is to filter the stuff out before it gets into the engine. Now, when you take the plug out of the bottom of the sump to do your oil change, all the oil drains out of the bottom of the sump and it drags all of that crud that's sitting at the bottom of the sump out through the drain plug. So it hasn't affected the engine because it hasn't been sucked into the engine. If it did get sucked into the engine, it'd be protected by the oil filter. And then when we do an oil change, we're dumping it all out anyway. So the fact that they're dumping this crud out of the bottom of the sump and then using it for the oil testing isn't representative of what's happening in a real motorcycle. And of course, once you put the plug back in and you fill it up with clean oil, well, then you don't have any crud in the bottom of the engine. And over time, over the service interval for this oil, whether it be 5,000 miles or whatever it might be, sure, more stuff is going to build up in the bottom of the pan. That's just normal machine operation. And then when you do the oil change, you take the plug out, you drain it all out again, you take all that crud back out of the engine, you change the filter because it would have been doing its job. And if there's anything that had gotten past from the oil had gotten into the engine, it would have gone via the filter, and the filter would have done its job. So the reason you change oil in the filter is for exactly this purpose. All right, tested objectively, they said. So they said they were using standard VDA19, and I had to go and look it up because I'd never heard of it before. And the reason is because I'm not in manufacturing, and this is specifically a standard used for assessing manufacturing cleanliness. So this is an old one, and the only one I could find was 2015. They're probably a newer one, probably updated, but for the purpose, you guys will see where we're going with this in a second. Inside that document had this particular statement, which I think is relevant, right? So a cleanliness specification is stated in cases where there is a significant risk that the function of a system or component could be damaged by particulate contamination. If no risk is present, a cleanliness specification should not be made. So if there's no risk to the machine being damaged by the contamination, if there's any contamination present, then who cares what the contamination is? If it's not a risk, then we don't worry about it. Good diagram in this document too sort of explains typical sort of failures that you might see if you did have contamination like this in the oil. So this first diagram here on this left-hand side, so those hatched boxes are representing two surfaces that would normally be sliding past each other. So it could be a bearing, like bearings and engines or bearings and turbos, whatever it might be. And that's in between them is an oil film. And that black particle they're showing there is bridging the oil film between the two components. Now, if you do get contamination that's sufficient to bridge that gap and that oil film, then sure, those two surfaces will be damaged by that particle that's between them as they're rubbing past each other. The other thing that's possible would be something like this in a valve. This is a spring and a ball, and there's a passage here, and the spring would keep the ball seated against this seat here, and any oil pressure where the arrow is that was exceeded the spring capacity would push the ball off its seat, and then oil would get past. Potentially, if you've got some contamination in the oil, if something got underneath the ball, then it wouldn't seat properly, and oil would always be passing past it, and that might cause problems with functionality, especially in hydraulics. In the bottom left-hand corner here, they've got a drawing of a cross-section of a fuel injector with very small, nozzle holes here that are used to atomize the fuel as it's pumped out at very high pressure. And again, potentially possible if you had some contamination that you could block or partially block one of those holes and affect the fuel flow to that particular cylinder. And again, in electronics, not that we have too many exposed electronics and exposed contacts, but in manufacturing where you're putting these things together, sure, if you had some sort of contamination that was big enough to bridge contacts, well, that could cause an electrical failure in a component. Again, these are all really critical when all these parts and components are all disassembled in manufacturing and you're putting them all together. So you have an opportunity when they're sitting on a bench or in an assembly line and you've got normal dust and normal things floating around in the atmosphere, it's certainly possible for these things to occur in manufacturing. Once the machine's been assembled, like a motorcycle, and it's been tested and you've done a couple of thousand miles on your brand new motorcycle, if any of this stuff happened to be in the engine, where would it be? Probably in the sump. So when you do your first service oil change, it all gets drained out anyway. So this is relevant for manufacturing, absolutely. For in-service testing of motorcycle oil, I don't think so. The other thing that's relevant I used to have this saying when I worked in earth moving is, we could build you a machine that was indestructible, but you wouldn't be able to afford to buy it. No different for manufacturing of motorcycles as well. Basically what they're showing here, hey, the cleaner you want this component to be, the more expensive it is going to be to do that. Now, manufacturers have to balance cost of these sort of processes, of cleaning processes, against what they think they can sell the motorcycle for. So they're not going to add $1,000 worth of cleaning to all these components if it's not going to make a difference to the machine and if they can't pass it on to the customer. So they'll make a call and say, this is clean enough for the purposes that we need it for. When I looked at the back of this document and had a look at all the participants who are part of the building up the documentation, you have a look at the list of automotive manufacturers. So we've got AGCO, Ag Equipment, Audi, BM, Daimler PKW, I think that's Mercedes Cars, Daimler Trucks, MAN Trucks, Porsche and Volkswagen. The supply companies, predominantly German, right? So you've got Bosch in there, Getrager Transmissions, Mahler Pistons and things, SKF for bearings, ZF for transmissions, and the technical suppliers and service firms, Paula Filtration. So I recognise some of these names, but the key to this one that really got my attention was Daimler Trucks and MAN. So in the trucking industry, for emissions purposes in diesel engines, they're very common to see common rail fuel systems in diesel engines. It's common in earth moving as well, but for emissions reasons, that type of fuel system is very common because it provides the best emissions performance for these machines or for these trucks. Now, on a common rail fuel system, absolutely, you need very, very clean fuel in those fuel systems because the clearances are, microscopic. That's how they get the high pressures in the fuel systems to get the high atomization of fuel, and then they get minimal emissions. So when I saw this, I thought, okay, so this is really a European standard for manufacturing, and the trucking guys are involved in it because of their common rail fuel system. So this is not, I don't see any motorcycle manufacturers in here, so probably irrelevant. Okay, so video 19, standard is used for assessing manufacturing cleanliness. And if you read the details of the document, it talks about the suppliers and the OEM, the equipment manufacturer, agreeing on a standard, and then the supplier being able to supply the equipment to the manufacturer at that cleanliness level. There's no mention of it being used for assessing in-service oil, as we saw in the video. And it's very important, as I said, for heavy-duty diesel engines with common rail fuel systems. There are no motorcycle people involved in this at all, and third parties like Fortnine and myself can't draw any conclusions about these motorcycles without knowing what, if any, cleanliness specifications were in place when they were manufactured. So really, in summary, the testing in this video has basically no applicability in determining the greatest of all time motorcycle manufacturer. So the way the oil was sampled is not representative of what's happening inside the engine, and the test methods don't prove whether any one manufacturer is better than the other. So yeah, mate, science sucks. If you've learned something from this video, give us a thumbs up, hit the subscribe button. Thanks for watching.